How GPS knows where you are. Every time you open Google Maps and see that little blue dot moving with you, it feels almost magical. Your phone somehow knows exactly where you are on Earth, even when you're inside a car, even when you're in a different city. But GPS isn't magic. It's actually a system of satellites, physics, and very precise timing. And the surprising part is this: your phone doesn't find your location, it calculates it. GPS stands for Global Positioning System. It was originally developed by the US military, but now it's used by billions of devices around the world. It works using a network of satellites orbiting Earth. There are at least 24 active GPS satellites constantly circling the planet. Each one is about 20,000 kilometers above Earth, and each satellite is continuously sending signals down to the surface. The key idea: timing. Each GPS satellite is basically broadcasting two things: its location in space and the exact time the signal was sent. That second part is extremely important, because GPS is all about time. Even a tiny error of 1 millisecond can cause a location mistake of hundreds of kilometers. So these satellites use ultra-precise atomic clocks. These clocks are so accurate that they would only lose about 1 second in millions of years. Now imagine your phone on Earth. It is constantly listening for signals from GPS satellites. Let's say your phone receives a signal from one satellite. That tells you one thing: you are somewhere on a sphere around this satellite. Because the signal took time to reach you, it traveled at the speed of light. So if it took a certain amount of time, your phone can estimate distance. But one satellite is not enough. That only gives you a big invisible sphere in space. Now your phone receives signals from a second satellite. Now you have two spheres. The place where those two spheres overlap narrows your possible location. Then a third satellite signal arrives. Now things get interesting. The intersection of three spheres gives your approximate position on Earth. This process is called trilateration, not triangulation. Trilateration uses distances, not angles. Why you need a fourth satellite? There's one more problem. Your phone's internal clock is not perfect. It's not an atomic clock like the satellites. Even a tiny timing error can mess up your location. So GPS uses a fourth satellite to correct time errors. That fourth signal helps your phone adjust its clock so everything lines up correctly. Once that happens, your position becomes extremely accurate, often within a few meters. Why signals travel at the speed of light? GPS signals are radio waves, and radio waves travel at the speed of light. That's about 300,000 kilometers per second. So even a delay of a fraction of a second changes everything. That's why GPS has to measure time with extreme precision. Because distance is calculated like this: the time the signal took times speed of light equals distance. So if your phone knows how long the signal took to arrive, it can calculate how far away the satellite is. Why GPS works anywhere on Earth. Since satellites orbit the entire planet, at any time your phone can usually see at least 4 to 8 satellites. That means it always has enough data to calculate your position, even if you're in the middle of the ocean, or in a desert, or flying in an airplane, as long as the signal reaches you. Why? It sometimes fails. GPS isn't perfect. It can struggle in places where signals bounce around, like between tall buildings in cities, or inside tunnels, or under thick roofs. This is called signal reflection, or multipath error. The signal hits surfaces and takes longer paths to your phone, which confuses the calculation. The bigger idea. What's amazing about GPS is that it doesn't see you. It doesn't track you directly. Instead, it listens to timing signals from space and uses math to figure out where you must be. So every time you see that blue dot moving, you are witnessing one of the most precise engineering systems ever built. A system that turns time into location and satellites into a global map.